going on, guys? Let's see how we can do this problem right here. The question is asking to find the area, right? So this is a region bounded by y is equal to root x and it's rotating around x-axis, right? So whenever we have area that's rotating around x-axis, we have to use this one. A is equal to 2 phi y ds, and if it's rotating around y-axis, we have to use 2 phi x ds. So that's the difference. So here it's rotating around x-axis, so we have to use 2 phi y ds. Now the thing is, this ds represents, like if you have learned the arc length formula, that is this ds is the arc length. And if you find, so first what we can do is we can just find the arc length and then plug it in this equation. So let's go ahead and find the arc length of this one. So let's see what's the formula we are going to have. So ds, if you remember the arc length formula, that is ds is equal to square root of 1 plus square root of 1 plus f of x prime dx, right? So this is the, and this is square. So this is the arc length formula, and here it's better to take dx because we have y is equal to root x. If we take dx, that's much easier. So first we have to find the derivative of this function. So we have y is equal to root x. So y prime is going to be, before I write that, I write this as x power half. Now we can find the derivative. Y derivatives prime is going to be half x power minus half. So this is same as 1 over 2 root x, right? Now we can go ahead and plug it right here. So this is going to be, and we are going to square it. Let's square it and plug it. Y prime square, that's going to give us just 1 over 4x, right? So this is what we are going to get if we square. And let's go ahead and plug it right here. So 1 plus 1 over 4x dx. And if I take the common denominator for this one, this is going to be just 4x is going to be my common denominator. And then we are going to have 4x right here plus 1, right? So this is what we have. Now this is and dx. And this is what we found from arc length formula. And now let's go ahead and plug it in this equation. Area is the one we are trying to find. And limits of integration is going to be 4 to 9, right? So actually this is integral 2 phi y ds. 2 phi y represents circumference, and if you integrate that one, that's going to give you area. So here we are going to have limits of integration that's going from 4 to 9. 2 phi y ds. So 2 phi y is going to remain the same, and ds is going to be this value we found out already. That is square root of 4x plus 1 over 4x dx. Since this is in dx, we have to turn this y in terms of x value. Then only we can do the integration, right? So if you notice the question, we already have y is equal to root x. So we can just plug this one root x instead of y right here. So this is going to be 4 going from 4 to 9, 2 phi root x square root of 4x over 4x plus 1 over 4x. Or I can just write, instead of writing like this, you know, if I write like this, I can cancel this 2 and root x. We know that square root of 4 is 2, and square root of x is going to be just square root of x. So if you notice, we have 2 right here. 2 and 2 cancels. Square root of x to square root of x cancels. So we only have phi 4x plus 1. And since phi is a constant and dx, we have dx right here. And since phi is everything except x is going to be a constant. Since phi is a constant, we can move it to the front. So phi is going to be phi times phi integral 4 to 9 square root of 4x plus 1 dx. Now how can we integrate this one? If you notice that dx is derivative of x, therefore we can go ahead and do the u substitution for this one. So let's do the u substitution. Let's continue this one right here. So here we are going to have, if I take u as 4x plus 1, so u is equal to 4x plus 1, then du is going to be just 4, right? 4 dx. Now we want to plug the dx. We know this is u. I have to write everything in terms of u. So we know that 4x plus 1 is u, and dx, we have to replace dx. We have 4 right here, so we have to bring the 4 to the other side. So it's going to be du by 4 is equal to dx. Now I can plug du by 4 instead of dx. So let's go ahead and do the u substitution. So here we are going to have phi integral, and it's better to find the new limits of integration, then we don't have to go back, right? So to find the new limits of integration, if I plug 4 instead of this x value, what are we going to get? 4 times 4 plus 1, that's going to give us 17. So 17 is going to be lower limits of integration, and upper limits of integration is going to be when we plug 9 instead of x, that's going to give us 9 times 4, that's going to be 36. 36 plus 1, that's going to give us 37, right? And then if I put u right here, this is going to be just root u, and then du by 4, dx is equal to du by 4. I can move the 1 over 4 to the front, so this is going to be 5 over 4 and du right here. Now we can integrate this one, and this is same as u power half, right? Square root of u is same as to u power half. So let's write it in that way so that make it clear. So 70 to 37 u power half du. If I integrate this one, that's going to give us 5 over 4, and we just have to add 1 more to the power. So this is going to be u 3 by 2 divided by 3 by 2. So 3, instead of putting 2 in the bottom, we can put it in the top. So times 2. And then this is going from 17 to 37, right? Now, since we have already found the new limits of integration, we don't have to go back to convert the u. We can keep it as u and plug the values. So here, this 2 and this 4 cancels. We have 2 right here. So we are going to have 5 over 6. And then this is going to be, if I plug 37 for this one, this is going to be 37 power 3 by 2. And then minus 17 power 3 by 2. And usually the questions ask for the expression. We don't have to go ahead and solve this one, right? So this is going to be the final part. This is going to be the area of this region, and that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.